We have little questions. Let's see today questions. Okay. So today question is 309. Best time to buy and sell stock with the cooldown. Okay. So this question 309 is the question to saying that we have to best time to buy and sell stock so that you can get a maximum profit. And let's understand how. So the question statement is you are given an array price where price of I is the stock price, right? And price of I is a array, right? Array index given I. So prices is the price of a given stock on ith day. There is some day, and price of I is a that day. Find the maximum profit you can achieve. You may complete as many transactions as you like. Buy one, sell one share of the stock multiple times with the following restrictions. After you sell stock, you cannot buy stock on the next day. So cool down 1 day. Okay, means if you want to sell the stock, what you have to do? You have to uh, wait at least 1 day. Alright, okay. So after selling, you cannot buy stock on the next day. You may not engage in multiple transactions simultaneously. So you must sell the stock before you buy again. Let's understand the example here. Input is given prices. Uh, Stocks, right? Given a stock at the day. Okay. So day one, that is I equal to 0, is given 1. Okay. The price of a stock is 1. I 1, it means 2, means price of stock is given 2, and so on. So it is giving the maximum profit he can get, he can achieve, or you can achieve is 3. How? So transaction is first we have bought the first day, then after 1 day we sell. Okay, after that day this is the cool down, right? So we cannot sell this, right, that day. We cannot buy this day because we have already sell this. So next day will be our cool down day. So next day is we can buy this, and after that we can sell this, right? So if you'll talk about we have bought in 1 rupees, we are selling on give me 1 minute, I'll take the pen. Yeah, so let's see. So first day we have buy, sorry, buy, we have buy at 1, we are selling at which price? 2 price. So the profit is what? 2 minus 1 is 1. Next day that is a cool down, right? Next day is cool down, so we are not going to do anything. What will happen? Next day we will buy, we are going to buy at what? 3. Now we have to sell, right? And selling price is what? 2. Correct? So as you can see that what we sorry, the 3 is a cool down, correct? 3 is a cool down. Next day is what? 0. Next day is 0. This is a cool down price 0, and after that we are going to sell at 2. So profit is what? 2 minus O is what? 2. It means total profit, if we'll see that 1 plus 2 is nothing but 3, and that's why we are getting what? 3. So maximum profit we are getting here is 3. I think you understood, right? So there is multiple ways you can do this program, but I will recommend to go through the approaches we have, right? So as you can see, overview is given. Like first of all, we would like to mention that there is another problem from the series of best time to buy, sell and stock problem. So there are multiple lists, right? So you can go through this list. I'll put into the comment, right? And you can go through. So one can try to resolve them one by certainly you can get the understanding. Okay, so we will come to here the first approach, that is a dynamic programming approach with a state machine. So this is little mathematical thing, right? So keep in mind that you will understand a lot of technique here. Okay, and let's continue. So question, the approach, in this approach we you can understand the state machine, right? What is the state machine? With a with a machine, which is a mathematical model of computation. Later on we will see how the state machine coupled with the dynamic programming. Okay, so in this program we will use dynamic programming with state machine. Okay, the technique can help us to solve the problem easily, right? So in this section we will first define a state machine, and that is used to model the behavior and the state of the game agent. Okay, so we will demonstrate how to apply the state machine to solve the problem. Definition is that, let us let us define a state machine to model our agent. So a state machine consists of three state, right? Three state. The first state is held, sold, and third reset. First is hold, held, second is hold, and third is reset. Okay, so in the held state, the agent hold a stock, the agent hold a stock, and that is brought at some point, right? Next state is sold, in which agent just sold the stock, agent has just sold the stock right before entering this state, right before entering this state. The agent hold no stock at hand. Okay, there is no stock in his hand. Okay, now reset. Reset is, first of all, one can consider this state as a starting point, right? The state as a starting point where agent hold agent hold no stock and do not sell a stock before, right? So agent doesn't hold any stock and did not sell any stock, right? So more importantly, it is also the transient state before the held and sold, right? This will come between, if there is a held state, right? If there is a held state, there will be another is sold state, right? There will be a sold state, and in between that there is a transient state, and that can be called reset. Reset. This is transient state. Okay, so due to cooldown rule, after the sold state, the agent cannot immediately acquire any stock, right? Due to cooldown rule, the after the sold state, right? After the sold state, the agent cannot immediately acquire any stock, but force into reset state. Okay, so one can consider this state as a reset button for the cycle of buy and sell transaction, correctly? So at this moment, the agent can only be in one state, right? The would trans agent would transition to another state by performing some action, right? Let's see the action. That is a, we can say, sell action, buy action, and reset or rest action. We can say rest is cooldown. So sell action, buy action, and reset action. The agent sell a stock at the current moment. When agent sell a stock at current moment, right? He sell a stock at current moment. That is a action sell. Action is sell. So after this action, the agent would transition to sell sold the stock. Correct. So after this section, after this action, what happened? Agent would transition to sold state. Correct. And in the buy, the agent acquire a stock at this moment, and after this state, the agent would transition to held state. And the action rest, this action, the agent does not, no transaction he is doing, neither buy or sell. Okay, so for instance, while holding a stock at the held state, the agent might simply do not at the next moment of the, and it will remain held state. So now we can assemble the state and action into state machine, correct? So which we show an following graph. Each model represent a state, and each edge represent a transition state between two. So on top of each edge, we indicate the action that triggered the transaction. Okay, so what we have understood in this, like there is a state machine, right? And that contains what? The behavior of the state, right? Of, you can say, as a agent, right? So how we apply the state machine to solve this problem is that you have to understand like the state machine and its state, right? So every state machine consists of three state, right? The held, sold, reset. And agent can only be in one state, right? So the transition to one state to another state, we can have only three actions: sell, buy, rest. Either you will sell, either you will buy, either you will rest. Okay, understood. So now you can see that in all the state except the sold state, by doing nothing we would remain in this state. So why is uh, there is a self looping transition on this state, right? So if we are going to start with buy, right? If we are going to do buy, we are going to buy, right? So after that buying, you have to hold, right? You have to held, you can say. And next, either you have, if you have buyed this, then either you will held or either you will do rest, correct? The next day is so cool down state, means you cannot buy or sell. But after the reset state action, what will happen? You will do sell, right? You will sell the uh, stock, right? So the next state will come what? Sold. Similarly, it will come to the rest state, cool down state, and you are going to reset, and the reset will set action. So you have to understand the action: buy, held, sell, sold, reset, right? So these are our state, right? These are our state. So you have to understand in all the state except the sold state, right? By doing nothing we would remain in that state, which is why there is a self loop transition in this state. Now there is a deduction, right? So now one might would, how exactly the state machine that we define can help to solve the problem? As we mentioned before, we model the problem as a game and the trader as an agent in the game. So, and this is where our state machine comes into picture. The behavior and the state of the game agent can be modeled by our machine. Okay, so this is given a list of stock prices, right, in array. Our agent would walk through each price point one by one. So at each point the agent would be in one of these three state: held, sold, and reset, that would define before. At each point the agent would take one of three actions: buy, sell, rest, and then we would lead to the next state at the next price point, right? So you can see here those, it is given 715364, right? The price from 0 to n, the price from, this is the index day 1, day sorry, day 2, right? Then day 2, day 3, day 4, day 5. What? This is called 0 to n, right? So either this gamer, he can either, what he can do, he can buy or he can sell or he can do rest. Again, doing the rest, he can either buy, right? He can buy or sell and then rest. Only these things he can do. So now if we chain up each state at each price point, we would form a graph where each path the start from the initial price point and ends at the last price point. So what we have to do, we have to reset a combination of transactions that the agent could perform through our game. So this graph, right, shows all the possible path that our game agent walks through the list, which correspond to all the possible combination of transaction to the trader can perform with the given price sequences, right? So in order to solve this problem, the goal is to find such a path in the graph that maximize the profit, right? That we have seen this graph, right? So in each node of the graph, right, we can indicate the maximum profit that the agent has gained so far in each state of each step. So we have to highlight the path that generate the maximum profit, and don't worry about them for moment. We will find and we'll see how to calculate, right, in the next section. So this is the price, this is the stage high, right? We have given price first in this 1 2 3 0 2, right? And it is saying that the action is sold, held and reset, right? Sold, held, reset. Okay, so let's see how. Okay, so as you can see here, or let's understand first the algorithm, right? Then we will come to here this point. Okay, so in the algorithm it is saying that, right, in order to implement the above state, we could define three state, right? Held, sold, reset. So only three state we have: hold, held, sold and reset. Okay, which correspond to three state that we defined before. So each element in the array represent the maximum profit, and that would contain gain a specific point one with a specific state. For instance, element sold to element sold at 2 represent the maximum profit we gain if we sell the stock at the price at 2, right? So according to the state machine, right, according to the state machine we define before, we can then deduct uh, the formula to calculate the value for the state array as well. How? Sold of I is what? Hold I minus 1 plus price I, right? Whatever the price we have at I, that plus what we have hold I minus 1, that, and that is our sold of I. Okay, next if we'll take held at I, that will come, we have to find the maximum between held I, right, and reset of I minus 1 minus price I. And the third one will come maximum reset, and that will do max of what? Reset, max of reset I minus 1 and sold I minus 1, correct? So how we implicate this formula? Sold of I is what? The previous state of the sold can only be held. Previous state of sold can only be held, and held could also be held, right? And the third, reset is the previous state, right? The reset of either can be reset or sold, right? So when we talk about sold of I, that is the previous state of sold, and that can only be held. So therefore the maximum profit of the state is the maximum profit of the previous state and plus the revenue by selling the stock at the current price. So held of I, the current state of held could only be held. So one does not do transaction, so or its previous state could be reset. So for whether a state can only acquire a stock at the current price. When we talk about reset, it means the previous state, the reset could either be reset or sold, but both transactions do not have involved any transaction of the state. So either finally we have to do maximum profit that we can gain from the game, and that will sold max of sold and reset. Okay, so let's understand this one. Though the animation we have given, and we will see the process, right? So three arrays are calculated step by step. So one, we are talking about price, hold, sold and held, reset, right? So initially what we will do, we have this array. Initially we have this array in which at index 0 we have 1, index 2 1 we have what? 2, index 2 3, index 3 0 and so on we have. So we have price, this is the price given. We have to find three array: sold, held and reset. So sold is INF, held is INF and reset is 0. So if we are talk about this one, right, what happened? We are sold is we are doing initializing, right? So this will be nothing but what? 0. And similarly this will be reset to -1, correct? And this held is remains same. The state is remains same. Similarly, if we'll talk about when we are going, so this was the initial value, right? At actually at 0, what happening? Reset is 0. We are not selling anything, means we are not doing anything, right? It means that is -1, and sold is nothing, right? We are not solding anything. Okay. Now when we come to this point, right, at 1, what will happen? We have to check sold. Sold is what? 2 minus 1, that is our sold. Then this will remain same. We are not holding anything, and because we are not holding anything here also, right? Next, the reset is we are not doing reset, right? We are not doing reset also. So reset will remain same as previously we have. Okay. Next, what we'll have at 2, we will come here, right? And that is our previously profit was what? 1, and that is this, correct? Now we are going to take this one, right? 2. How? This is 1, this is -1, and this will remain what? 2. How? Because we are not doing anything here. We are not doing anything. This is a reset, right? This is reset. And so we have sold that, right? We have what we have sold here? 2. So sold will come here. Okay. Here we were solding, right? So solding is here, and when we are solding this one, so solding is here. Okay, but we are not holding anything because this is cool down and we have already sold this, right? And at the reset, what profit I have? You can say we have already did the profit, and we can save somewhere a profit, right? Now when we will come here, right, so we are not solding, right? We are not doing sold, so this will remain same. Now we are doing held, right? We are doing held, means we are going to buy. So already I have P at 1, right? Profit already I have, that will come here, and we are doing what? 0. We are adding, right? We are buying this one, and so that I have held something, but we do not do reset, and so that previously we have 1, now we are buying something, right? And that we can take as a 2. Next time when we will come at last index, right? So what happened? Now we have sold, right? 2 minus 0 is 2, and 1 profit was previously, and that is nothing but these 3. Okay, and we are not solding anything, right? We're not sold. We have sold, actually. We have sold. That's why we did 2 minus O, and next time we are doing reset again, right? So we have what? 2. So in this way, as by the product of this algorithm, right, not only we obtain the maximum profit at the end, but also we could recover each action that we could we should perform along the path, although we look at the problem, right? So in this below program, right, below graph, you can see that by starting from the final state, walking backward, following the path, we could obtain a sequence of actions that leads to the maximum profit at the end. Buy, sell, cool down, buy, sell, correct? So as you have seen, right, what we have did? First we have did buy, right? Buy, sell, and then buy, sell, and cool down, buy, sell, correct? So if we'll talk about the program, right, how we can do that? So there is we'll take sold, right? Sold is nothing but our minimum value. At minimum value we are solding, and holding is also minimum value. So we'll take reset is initial as a 0. Okay, and for all the prices we will make the loop, right, from index 0 to at index n. So all the loop we will make, right, all the loop at 0 what I have, so we will get initial price, right, and what we have to do, we have to pre-sold, right, we have to get the pre-sold value. Okay, so pre-sold value is nothing but sold, right. What we'll do, what is the held value, right, we, we have some minimum value, right, initial value some have, so initial value plus price is sold, right, so we will get sold here. Okay, then held we are calculating between what is held, what is held is max of held and reset, whatever the reset we have and the price, right, means the reset minus price will do and held, right, whatever the data will come that will come our held, and another is reset means reset and pre-sold, whatever the reset value we have and pre-sold value we have that will come our reset, that previously we did, right, and finally we'll check the sold and reset value, what is at sold value, what is at reset value, and that is whatever the maximum value we will have that we will return as a profit, correct. And then if we'll talk about the time complexity, if we'll talk about time complexity means O of n, because n is the length of the input price and we have one loop over the input list and operation within iteration that takes constant time. And if we'll talk about the space complexity means constant time is used regardless the size of the input, correct. So time complexity O of n and space is 1 because we are not taking any extra spaces, but O of n is because we are making one loop for all the input prices, right, and the operation is taking at constant price, right. So please ping me in the comment box if you really like this thing. What we have to do, we have to take the sold, right, we have discussed, right. So we'll take sold is nothing but what, we'll take an integer dot the max minimum value, right, we have mean value, right, that will take mean value. Next what we will take, we will take integer type held, right, there are three things we have to take, integer and the similar, right. So I can copy this one, minimum, we are initializing with the minimum value. Next what we will take, we will have a reset, right, so we'll take int reset will start from what, 0. Okay, so three actions we have, hold sold, held and reset. Okay, now we have to make one for loop, we have to make one for loop, that is int price and the price will start from what, the price is array, and this is nothing but this one, right. So we have to take a pre-sold price, we will take one pre-sold price, and this pre-sold price is our initial value of sold, right, and we will update each time. Now if we'll talk about sold, we'll give me 1 minute, we'll take one sold, right, and this sold is nothing but what, held, right, so the sold price is the held price and the price. Okay, so now we have sold. Now we will calculate held, right, so for the held what we'll do, we'll do math dot max, correct, the max dot max dot math dot max, and we'll take held what we have held and then reset minus price, correct. Next what we'll do, we'll do reset again because now it's cooldown, and we'll take math dot max again, and this is nothing but reset between reset and pre sold, correct. And after this for loop is completed, we have to do very simple, we'll do return and whatever the maximum we have, math dot max of what sold, what we have sold value and reset value, that we will return. Correct? So let's compile. Yeah, it's working fine. Let's submit. Yeah, very good. Thank you so much, guys. If you'll continue another approach, please let me know. And if you want to see the another approach that we have, so we'll continue that if you like this one. Thank you so much. Please comment and subscribe the channel.